So in this one, we want to compare the wavelength of an electron and a proton. We know that the mass of the electron is less than the mass of the proton, and that the wavelength of something is given by h over p, where p is the momentum. And in part A, we're told that these two have the same kinetic energy. So the kinetic energy of the proton is the same as the kinetic energy of the electron. And we know that the momentum is equal to the square root of 2m. So in this case, if the electron and the proton have the same k, but the electron's mass is smaller, that tells us that the p for the electron is less than the p for the proton. And so if the momentum is smaller for the electron, then it means that the wavelength is bigger for the electron. So the wavelength for the proton is less than the wavelength for the electron. And so the proton is the answer in this case. Now in part B, we're told that the p for the proton is equal to the p for the electron. Now if the p's are the same, Planck's constant isn't changing, so this tells us that the wavelengths are the same. So same. And then in part C, we're told that they have the same speed. So v for the electron is equal to v for the proton. And the momentum's given by mv. So in this case, the momentum for the electron, because it has a smaller mass, is less than the momentum for the proton. So it's the same situation as up here. And so because we're dividing by this, this tells us that the wavelength for the proton is less than the wavelength for the electron. So this is the proton.